very much. Thanks for the introduction. My name is Jonatas, and yes, I came from Brazil, and I'm here to talk about grepping SQL code like a boss. And that's my third time here in Poland. I'm very happy. I love Krakow, and more than talking about grep or regular expressions, my intent here is inspire you to also build your own, let's say, primitive tooling. So that's all about like small pieces of code that can help us, and I'm going to talk about a lot of steps in my adventure. Well, I am 2 decades in the terminal already, and this is very hard to give up, and it's very hard to just find another tool that I can fly like I do in the terminal, so I feel very productive, and it's not easy to find something simple as I/O, and what I love is that we have these very small building blocks that we can start. So like my talk today, you can expect 60 slides, and you can expect that you see like 29 Ruby snippets and 5 SQL snippets and 9 bash outputs. So that's the like very simple thing that I love. Like I'm just building everything in the terminal. I can count things, I can do things. And that really inspires me to like, well, I love grep. And then I was like, several times I feel so bad on grep, like I cannot do what I want. And then I was like, well, I think I need something else. So that's my journey. And everything started in my previous company when I was here with one very boring task that was onboarding developers, and especially like putting rules and more rules to everybody. So you have like that huge template, pull request checklist that you need to tick everything before you go. And then I was like, no, let's move everything to linters. Let's educate people on demand, because if you put too many things, several of those things are not like really necessary. Sometimes people are working on one place location, but the pull request checklist covers the entire system. And then you really get frustrated ticking, cleaning and things and doing things like that. So I was onboarding backend engineers, and several times I was repeating like, hey, do like this, don't do like that, do like this, don't do like that, do like this, don't do like that. And this really frustrated people. So if some linter is telling them that it's not a personal thing, it's something from like computer to people, and it's much easier. And that's like, oh, if there's a code, this is an agreement. I cannot go against it. I don't have anyone to discuss. I cannot be complaining with the linter message, right? So that's much easier to follow. So along my career on this company, I started introducing linters for our internal frameworks, for everything that we do that we could automate. And when I left, we have like 70 plus linters and a lot of different like custom rules to help the folks. So I really appreciate that I was able to, let's say, automate my own work during this time and learn a lot about abstract syntax tree, and that's the point here. So you can automate part of the education and part of the things that sometimes you also don't want to discuss with people. Like sometimes it's an agreement, like, oh, use the framework X or use the framework Y. It's already an agreement in the company, or like the way that people are building things. So it's much better to just like be looking for ways that people can be just like finding the way themselves than like tutoring or mentoring them on the go. And I really love this approach of like smart stuff. Generally, they are simple. Like smart stuff is not like complex things. This is like a set of simple things that just glue well. And my career, I love Ruby because the REPL idea of like you just go and like do a few beats and you have some way that you can understand the code. And I was really into like several frameworks. So most of the time I need to start like, hey, to understand this code, you need to go to this file and get this method, and from this method you should go there, and then you should go there. So I was always trying to navigate in the code with people, and then I come to some time that I say, I need something better than grep. I need to find something that I can highlight specific code blocks, and grep is cool. Like, I will just show a small example on grep, because like, if I do here like grep, for example, match in this file, and then you see, I have match, and I have file, I have comments, I have variables, I have method definitions, everything together. And then if you are a bit more expert on grep, you can say, for example, -b for before, so you can say print 2 lines before. So now you have a scope, and then you feel like, whoa, I'm getting where I am. So you can also go and say append after 2 lines. So I would like to check, and sometimes you see, well, it looks like the method that I want, but sometimes the method is also like some code example or an output, so it's very hard to get. And my idea with def, with fast, that's the tool that I'm going to show you, is just like you search from the abstract syntax tree, so you can use this syntax. Let me put the first line. That's a kind of Lisp syntax that you are expecting the entire abstract syntax block. So you say, well, I would like to have a match that matches my code, but it also should be a def that comes from the define method. So that's how it works. And I am a Rubyist, and in the last few years, I'm just like, I still do very little Ruby, but my work is more like on Postgres. So I'm also saying that I'm becoming a Postgres because of that. I don't know if this word exists. And Timescale, that's the company I work, they build like Postgres extensions to improve performance for different types of workloads. And my work is like 50% community manager, 50% developer advocacy, and it's much more about SQL. And I worked on this tool for quite a few time, like a few years that I was exploring, and then I was like, can I do this thing for SQL maybe? Like, can I try to just make this abstract syntax tree converge into the same syntax tree and reuse all my tooling to do things? And yeah, I can do that. So I did one talk in Krakow that was about this node pattern that is actually the same language that I'm going to show you today. And my idea here is show that this compiler is very simple, like it's like less than 300 lines of code, and this is the parser, not a compiler, but just a simple parser that you can build rules and explore the abstract syntax tree, and also be refactoring code or building something bigger. And I started using this from Rubocop, that is the Ruby linter. So they have this internal language, and then Rubocop is like 100,000 lines of code, and then I was just using like 300 lines from that. And then I was like, let me build it myself and learn. I am not like a computer science guy, so I didn't have like the proper compilers classes, so I was trying my first time. And that's how I went to this project. This is, I call it FAST as a way to find abstract syntax tree. And I couldn't spot the official library name, so I need to use 2 Fs. And yeah. And my journey here was more like in the idea of that I wanted to do automated refactoring. So I did a lot of different automation in the past. For example, when you are doing a test and then you have like sit up and tear down methods and this type of like before, after that you do cleanups. So you can do something like, what if I get this test and remove the tear down? Will it run? Will it run? Okay, or I can remove the sit up. And sometimes, especially in Ruby, that's a scripted language, things just work without the things that you have. So one of my tests I did was like 3,000 different test files. I put it to run in a week just to see like, what if I remove the hooks before and after, set up and tear down. And in a week I found 2,000 files that was like copying and pasting things over and just like not like really needing the code that was there. So that really inspires me to like, hey, I can do a lot of research with these and just like be injecting some of these experiments over and try to build new things. So regex is very powerful. I use it most of the time. And sometimes you cannot do things with regex because you need to set up contexts. Like, oh, I'm doing some search, but this search is like nested. And generally, you want to go over like some initial search, and then you need to go deeper into more and more detail. So, like generally, you can do it with regex, but the regex will be so insane that you never remember how it works. So, I think it needs another tool. So, this is like regex, but a regular expression engine for AST. So let's start with the basic of AST. So on AST, like a simple number one, it will have only type and children. And the type is the head, so it should be an int. So if you go to the children, it's the value itself, right? So generally, the output of the string expression that represents is something simple as open parens, and then you have the data type, and then you have the children. And when it's a leaf, it's the final value. And when it's another structure, then it goes further. So for example, in Ruby, operators are just methods. So when you call like 1 plus 2, you are sending the method plus from 1 to from this case is the number 1 to the param. And then you can think like, but yeah, it will be complicated. But the good part is like, for example, it can unify the code. So for example, you can use the ternary operator sometimes. Sometimes you are using an if. And then like if you want to check such type of like different types of operations, do it with grep. In this case, you feel like already hard to wrap both cases. And Ruby is funny, and it's full of exotic keywords like unless. You can use unless, and then unless is the same. So, and when you just try to check the AST of unless, you see that it's a if-else clause, so it's more of the same. And then you can also capture such things in this abstracting level. And as just the example here shows, if it's showing the entire clause. And then in SQL, the cool part is that we have a similar thing. So if you're not familiar with Postgres or SQL itself, select star from is a way that you query the entire relation, and then you can also say table. And that means exactly select star from. And that was my first assumption that I want to see, like, hey, is table exactly the same? Yes, they are the same. So this is a cool thing, and I can just start looking to like different trees in syntax, but they are going to go into the same means. And welcome to the SQL AST. So it's not simple as Ruby one, and this is much more complex, but this is how what it looks like, very simple. So you can see this is a select statement, and then you can see like it has a target list of elements, and then it has a from clause that has a rel name, and so on. And the simplest AST is like a select without the from clause. So you can see that like some trees have different types of leaves and trunks and so on. And what the fast do is allow to search and match these things. So you can just search by the head and compare type to type, and then it will just bring the things. And that was really my pocket knife too. So I haven't brought it for like other people. I was thinking like, I am the user. I need to build it for my needs. And then if someone finds it useful, they can use, but I will try to cover what I need now. And then I have a few users, but like the main idea is like, yeah, this is something homemade, so be careful and just learn with that. So here is an example that you can see when we start using parents, we can go further, and then, for example, underscore introduces the first operator that matches anything that's not new. And then you can start combining. For example, you can use the curly braces to combine, like it can be int or float. And you can also combine things using also methods from the final, let's say, the final values that are in the leaf. So you can also check like to.positive, that's a thing in Ruby. So you can also do this type of thing. And it contains a few operators. So I did this, and let me just show you the fast finders here. So for example, so this is a shortcut to just show all the finders that I have, and I also have fast dot. Oops. Yeah, and this is the parser. So the entire expression parser is just like understanding what are the operators, and then I build one class for each operator, and then this class just receives the abstract syntax node, and it tries to match the only node that is available, and then I have like a recursive system that can keep traversing all the children, and that's not that complicated. I took a few time to just like make it like beautiful, like just like the sequence, and trying to refactor it to be readable. And this is the main way that we unwrap the expression into real matchers from the Ruby ecosystem. And this is how it started. So just one a bit more complex example here, like a local variable assignment. So you see LV ASGN, so it's just a shortcut. And here is the support for SQL. So the thing on this is that the parser itself, it was not done by me, of course. Like this is done by Postgres, and Postgres offers the abstract syntax tree in C, and so other guys, they build a library named the pgquery, and basically this pgquery.parse is the thing that brings the tree here. And my work here was more on making this clean structure that is like, hey, let me simplify this abstract syntax tree that is very huge, several things and options, and make it simple. And here is a simple shortcut. So this is as a library for developers. I also built a fast file that's a place which I can collect and keep my patterns. So for example, in this case, like this previous slide was generated just using this shortcut. So if I'm here, I can just say SQL parser, and then I will just have the SQL parser definition. So I built a lot of different fast files for the projects that I was in the past. So when I was walking people through the code, I could just like show and highlight the most important things. And then the cool part on this is build the refactoring operation. So you can replace things. So for example, in this case, rel name is just the abstract syntax tree type node from the from clause that refers to another name, and then you can you can switch something in the abstract syntax tree and get a new SQL output. And you can also do it with more things. So, for example, here is a simple SQL formatting stuff. So you can check like, oh, this is a reserved keyword, so I will upcase this. This is not reserved, I can downcase, and so on. And yeah, you can see like with 20 lines of code, you can just build a small formatter that can do some stuff. And sometimes it's so hard to just like wrap up discussions about like, is it upcase or not? So I just feel that these pieces of code are so useful. And I also built a SQL anonymizer, something very useful. Everybody needs it. Like you start using SQL and you can't share your table name or your column names and things like that. So, and using abstract syntax tree, you can say, oh, what type of nodes I need to abstract? Oh, I need to abstract variable names, table names, column names, and so on. And these are like simple examples that allow you to learn, and you can see here different expressions that we use to capture parts of the code and refactor and build things. And now I'm going to talk about my latest experiment. So this is the hardest one. So basically, at Timescale, we built this Timescale DB extension that is something that automatically partition a table by time. So if you have a timestamp column in your table, you can just split your table every week or every month, or you put the time range that makes sense for you. And then this is really making Postgres faster for like when you have like billions or trillions of rows. So you can just make like better query plans if you know like the person is querying something from last year or last week. So you don't need to go to these big tables and long scanning. You can just find another map of your data. And then we call it hypertable. So we create this hypertable. So in this case, it's just like I'm going to track temperatures around the world, and this is by the range time every month. Oops. I have something that tries to run my code. So sorry. And here is some insert examples, like what it looks like. It doesn't matter here. But here is the real example. So I have a query that I use this time bucket. So time bucket is like a date trunk, something that you group by 1 month or 1 hour or 1 day. You just put your frame and you start grouping your data. And the thing is that like timescale, oops, I'm just using the wrong thing. Yeah, timescale just to build something that is extension on the materialized view level that you can also make your queries be, let's say, materialized and avoid reprocessing. And just to let you all know, I am in the marketing team and I am very connected to growth metrics. So we have a problem that is like people know that we have this, but they don't use. They start just like querying the raw table and it's fast enough and they never come to materialized view. So the thing is, we want to increase the adoption of this feature because this feature is unique for our database ecosystem. And then I was like, how can I make a linter that can teach people that they are using something that's already available for them? So that's the idea of what I'm going to show. So we have this previous query that is the time bucket, and then we have this actual materialized view. And the idea is how we can say, hey, buddy, you are trying this query, and this is a hypertable that already has a continuous aggregate. So you can use the continuous aggregates instead of going there, right? So that's the idea of my example. So the first thing is find the minimal piece of code that you can compile in your language that you can look the abstract syntax tree. So you go and you search for like time bucket. So time bucket, and you get this select statement, but what I want here is just this part, like func call, func name, string. SVol time bucket, and then I have all these types of different things. So I need to build this as an expression, and then I need to bind it and start collecting more pieces. So that is the thing. So here is a simple, let's say, I was thinking I would like to have something readable to show. So I am mixing here. When you see hashtag call time bucket, it's a method. It's an external method that can also like keep digging into details of abstract syntax tree. So what I want to search is for something that's calling this time bucket function, and this is coming from a hypertable because this also should be on, let's say, our framework ecosystem, right? And then I need to search all. So if you go deeper here, the call time bucket is just like doing the pattern, func call, func name, string vol, and so on. So it's checking if this is really calling the func name. And then I have another one that's the from hypertable that I need to check if this hypertable really exists in the database, if this is really available there. So I mix these two rules here. And then during the search all, I start collecting. So I see like, wow, this is a query. This is just a select statement. I will collect on queries. Or if the node has ancestors, like probably this is coming from a create materialized view as the select with this query. So I am matching both patterns in the same goal. And then I'm just like trying to store them. So here is my example. Like if this is a create table statement, then it comes with this $sign that is saying capture the name of where it's coming from. What's the name in this case? What's the materialized view name, right? And then the cool part is that like query temperatures will be equal the materialized view. So this equal is like a really sign that both abstract syntax trees are the same. So I can check like, oh, the materialized view content is exactly the same that I'm trying to query. And then I just iterate over all the queries I have and all materialized views that I have, and I check if any of them match. And then I can say, hey, buddy, the table name is tracked, and then we can report the table source and just give you a tip, say, hey, select star from your materialized view. You don't need to do that select. So that's the linter. So that's the demo. I will just run it and show you in details because I also have demo here. So this is a full file that contains the create table, select, inserts, the query that we mentioned, and also the materialized view. And so the check query now will run, recognize both cases, and also print it out if it works. So yay, it worked. So in this case, it's just detecting the things all together. But yeah, that's just an example. And this is the thing that I was supposed to show. So this is all about primitive tooling, and like sometimes it's like you have just a knife and you are in the jungle and you want to have food and have a meal, right? So you need to find a way to make progress. Sometimes it's so abstract to make progress in large code bases. I build fast, and I built a few other tools in the top of fast in the past. Like I built one tool that was analyzing multiple projects in parallel and trying to understand like the code mass similarity. And then we would use it with the architects to catalog what are pieces of code that we can extract to like service-oriented architecture or things like that. So we use this also to track the complexity of the code and also like estimate how much you can do if you are going to extract. And another tool that I built on top of it was also extracting a preview of a monolithic architecture that you need to decouple it into microservices. So it's a very long-term project. Like when you are extracting things, it's hard to preview. So I built something that I was just creating a new project and moving all the code over, moving all the tests over, running tests, adding new tickets to Jira, closing tickets on Jira, doing everything in the linter level, and also use this library to extract pieces of code and move things around. So this is very cool, very useful in general. And I don't want you to use my tool, but I am here really to encourage you to build things like that. And I see most of the language doesn't contain some, let's say, regular expression for abstract syntax tree in general. And it's not hard to build, so that's the main idea. And I'm also maintaining the timescale DB gem that's like just a wrapper for the Ruby folks. So this is the ORM level, and probably my next step is just like try to check if I can validate, like if someone is querying something that they can swap. I can even do like a real-time validation, run both queries, validate things, and offer linters for people. So I see a lot of potential on this type of work. Even it's far from the C part. So my dream was going to be implementing it directly on Postgres, like, hey, can I go on Postgres, learn all the internals of Postgres, go to Query Planner and just nail it? Yeah, it's still a long path for me, but yeah, at least I was able to make it in a small Ruby example and do the change. I published the talk outline today, so if you want to see it, my website is idea.me. And the last blog post is about it, so grepping SQL code like a boss. I also built several other posts in the past that was related to supporting SQL, building this SQL formatting, or anonymizing the SQL. So if you are curious about it, I have everything very well documented. And I would like to give a special thanks for Timescale for supporting me on this trip to allow me to come and do this talk, and also for Lambda Days for this amazing opportunity to be here. And yeah, I also wanted to talk with the Ruby community because most of the code, it was not built by me. Like most of it is just like these amazing building blocks that we can get from other folks and start building our ideas on. So this is most important thing in the world is adoption of things. So I love to work on open source projects, and it's very important that we are conscious about our decision of like building our things or contributing to a bigger thing. And I would like to encourage everybody to contribute to something bigger than just trying to build your own castle yourself. And it's much more cool when you embrace a community and you learn and grow together. But never forget that you can do things like that, and you can just like do your prototypes and things, and it's not hard to do. So yeah, thank you very much. If you want to talk to me, my name is Jonatas. You can find me on GitHub or Twitter or LinkedIn. Thank you very much.
So we have a little bit unusual situation because we have plenty of time for questions. So please use it to the fullest.
Hello, thank you very much for the talk. It was really inspiring, all this tooling in Ruby. Yeah, I was wondering about the AST and parsing. So it can be quite challenging sometimes with, well, very featureful languages, let's say. Have you thought of like mixing maybe some regex and the AST approach, like not just the AST, because it looks very daunting to do very specific niche things.
Yes, I mix it a lot. I also do this. Sometimes I even want to put a grep inside my thing. And I can say, for example, depending on the level of your research, like for example, multi-project research is much different than you do like one single thing. And for example, one attempt I have was to try to build a generic search, like, oh, I would like to search for a client or bill or billing, whatever, and I would like to get everything that is really connected. So I was building something that was exploring like, hey, I'd like to take billing out of the system. How I can extract the billing. So I need to get all the components that they are connected and start looking for the edges that I can cut off, and that's the main idea. And the hard part sometimes on the AST is that you get into let's say a lot of details that the developers of the language they have more reasons to think about more detailed things. For example, let's say you were talking about defining a function, and then when you are thinking about searching the function, you don't think about the signature if it's stable, immutable, or things like that. But this is already tracked there, and then like, oh, should they make it part of defaults or not? So in my case, I use this Ruby gem named parser that is the most, let's say, complete parser out of the Ruby compiler itself, because the Ruby internally they have like a VM that you can extract, but it's not like a simplified AST. So my main struggle was like in this simplification process, and still sometimes I fall back into like mixing the methods.
So you mentioned that you created a formatter as well.
Mm-hmm.
But in formattings, what you often want is not an AST but a CST, because you care about white space, for instance, and comments. How did you run into that, or?
Well, comments, they are not part of the AST.
Exactly.
They are. It's interesting. This is a cool analysis that if you see like how people search for the comments, it's the vacuum space between the AST nodes. So you have like a statement, and it starts on X and it goes to Y, and then you have another statement that starts on Z. So between Z and Y, you can have a comment. So then you need to have like an extra, let's say, AST processor that just process comments, and then you can attach them as like pre-of nodes or after nodes. I got several very complicated refactoring moments that like because generally when you start folding refactoring, you have like the reference of beginning and end, and then like you have the expression. So I will show you one example here because we have time, so let me move on. So if I have it here, let me just increase the font. So I have this local variable assignment, and this is just a simple thing, but let's go to the first children here, for example, like children, and then I can get the second children that is a node, so the children 1, and then I can get here lock. So this is the location. So you can see here, like this is from 4 to 5, and that's how you can get all the things around it, and everything just goes through the expression. In different nodes, they don't, sorry, not the node, the location of the node, it can be not an expression, but also something else. So generally, you verify what type of node first, and then you proceed to the implementation. I just put the QR code that goes to a GIST file. It contains all the examples that I showed you. Yeah.
Okay, thank you for the great talk. I have a question about the thing you mentioned in the end, precisely about comparing repositories on a structural level that you did with other architects. Can you elaborate on that a little bit, because that really got me interested?
Yes. So especially when you are building, for example, let's say you start decoupling your. I started this project in a company that has a big monolith, and they were extracting services. So several times to extract the services, they start copying files to not like, oh, I will not build a library just for a single file. So, and then you have sometimes exactly the same file, but sometimes the file is just in another module. So only the first module name wraps differently, the rest is almost the same. So what I built, I also have a very good documentation website, and in here in the, I can show you here, yeah. Code similarity. This is a small tutorial that shows you how to build like a matching for similarity, that you can also start like building this. So I was working in something that was kind of code mass visualization that was like, hey, how much % of the mass of this abstract syntax tree matches the other one? So, and then from this similarity, what we use to get like, oh, it's 99% equal. And then we start like, for example, you can do some tricks and anonymize some of the constants and things, and then you get more or wider or less. And we use it as also a kind of linter that we can extract signature of the method. So you see like, oh, this is a total anonymized method, and you find the exactly same method just with another parameter name or just a name. So, and it was very useful. Thank you.
This is going to be the last one.
In the materialized view example, you show that you are comparing the select query syntax tree with materialized view one.
Mm-hmm.
But have you considered the same syntax trees that are semantically the different syntax trees that are semantically the same but are different generally? Like we can have the if condition for where condition where couple of attributes are checked, like, and we can swap the end condition there. And how you handle this case?
That's the point of you start analyzing specific nodes of the tree. So, for example, let's say you just ignore some fragment or ignore a leaf, or like you go and strip both the leaves that you don't want, and then you focus on in the matching part that you want. The cool part here, for example, like in this query, I'm just using, for example, here I have this ENH true. If I don't pass it, it will still match. Like I'm just building this more complex scenario, but if I want to remove like, oh, I don't need this, maybe like I want to check these two things, that is the namespace of timescale DB continuous, but apart from that, like the only thing I want is the rel name here. And then I am just matching the entire thing to see, well, no, I am in a materialized view, this is all about timescale DB continuous and so on, but I'm not checking like extra where clauses, I'm not checking anything. And then if I need to go into the final comparison and ignore it, I will need to discard this part of the abstract syntax tree. So generally what people do is they work in a tree builder. So you create a tree builder that builds another tree that cuts some edges and cuts some trunks. So it's a simplified tree. Generally, at least from the examples I saw in the parser, you just create a new builder of AST that also process your things.
Okay, thank you very much again. Another round of applause for a brave traveler.
Thank you very much.